Hi, my name is Brian Toaz. I'm an engineer here for Bilz Vibration. Okay, so we're over here at the platform now. The platform's setting on a pallet jack. Because it is a smaller CMM here, we're able to use the pallet jack to facilitate the lifting. Some of our larger platforms, customers need some kind of forklift or other means of lifting the platform in place, but in this case we'll be using instead of pallet jack. On top of the platform we have here the air springs laid out. This is kind of a typical layout for a 4 air spring system or platform like we have here. You're going to have 3 points of level control facilitated by these level control valves mounted to the air spring itself. So you have 4 air springs, so 2 of the air springs will be teed together. So you'll have a supply line of air coming into the level control valve, and that will control 2 of the air springs. One of them will act as a slave to the other. And then you'll have 2 other air springs that are independently controlled of each other, both having level control valves on it. And that's done because the 3 points of leveling is much more stable, much more easy to control. And each platform system will come with a schematic that shows the tubing layout for that system and the air spring orientation under the steel plate platform. So the first step to installing the platform, we have these wood blocks here and just a little shim plate on top, and you're going to want 4 of these blocks to install under the steel plate, and it's key that the blocks are just slightly taller than the air spring's deflated height. And that's because once the steel plate is setting on the blocks and the pallet jack is removed, you want to be able to slide the air springs underneath the platform. And then the air springs will be used once they are inflated to remove the blocks once the system is completely installed. So we'll go ahead and use the pallet jack here to lift the steel plate to the proper height. And you want to make sure you're placing the wooden blocks in a position that isn't going to affect where you want to put the air springs later. Okay, so now that you have your 4 blocks in position and the platform's ready to be set down on them, you can lower the platform down and move the pallet jack. Instead, some people this might be a forklift. All right, we're back over at the workbench here. We have an unassembled air spring. So when the system shipped, the level control valves and GDR rings will be shipped loose, not installed on the air spring, and as well as some shipping screws in the top of the air spring to keep the piston free. So we've already removed the shipping screws from the top of the air spring, and it's ready to have the level control valve installed. We'll flip the piston over here and get ready to install the level control valve. So in this case, for this platform, the customer is using our LCV high flow valve, and in this application with this air spring we need to use a plastic spacer as well. So just line up the level control valve with the spacer holes and bolt this down to the air spring. Once the level control valve is mounted in place, like I said, you might not always need a spacer. In this application, the customer did need a spacer. You'll go ahead and install the GDR ring in between the body of the air spring and the piston. And then there's a hard metal plate that gets epoxied in place between the top plunger of the level control valve and the piston of the air spring. For the purpose of this video, we're not going to epoxy this in place, but it would just go in position right here. So as I said, this customer is utilizing our LCV high flow level control valve, but we do have a couple other options of level control valves that could be used with these platforms. One of them is our standard LCV valve, and this is the same valve that's on here, just a little bit lower flow, a little bit slower response time. Also, we have our PVM valve. This is a little bit better repeatability accuracy than the LCV valve has, and a little bit better performance when it comes to vibration isolation. Like I was saying before, we have this hard metal plate that gets epoxied in position on the bottom side of the air spring piston, centered on the level control valve plunger. Some customers, instead of the hard metal plate, choose to use our pad A, which is a piece of foam sandwiched between two hard metal plates. And this helps to reduce the effect of transmission of vibrations through the spring of the level control valve and help dampen out the vibrations better. So now that your air springs are all assembled and the blocks are under the steel plate at the right height, it's time to install the air springs underneath the platform and hook up all the air lines. So in order to get the blocks out from underneath the steel platform and get the platform resting on the air springs, you'll have to use the air springs to lift the steel plate. Because the steel block is taller than, because the wood block is taller than the air springs, you have to stroke the air spring slightly higher than its normal operating height just to get the blocks out before you deflate it back down to its proper operating height. So the next step is to hook the system up to air and float the platform so we can remove the wooden blocks. As you turn up the air pressure on the pressure regulator, the steel platform will slowly start, or the air springs will slowly start to inflate, and the platform will slowly start to rise. Once the platform is floating, you're able to slide the wooden blocks out, and now the platform is slowly resting on the air springs. Once the blocks are removed, you will want to deflate the system. There's some initial height settings that you want to adjust the level control valves to before re-inflating the system for use and leveling. So to adjust the height of the level control valve and the height that the platform will float at, there's a knurled adjustment ring at the top of the body of our level control valve. And as you thread this knurled adjustment ring, it will raise and lower the body of the control valve and adjust the height of the platform. As an initial setting for floating the system, typically we adjust this knurled ring up until it loosely lifts off the fittings of the level control valve. Then we adjust it back down so it just comes in contact with the level control valve fittings, and that's the proper initial height for the air springs. Hooking the air springs back up to the air supply and allowing them to inflate with initial settings, the system should come up and begin to float. At this time, you would go around and check the gaps between all of the air springs and the air spring body and the air spring piston. and you're shooting for about a 5mm gap. Typically,
About the size of the tubing.
for an installation, the gap is about the size of the tubing we use to plumb up the air springs. So that's a good gauge to see if the air spring is floating at the proper height. As I check this one here, it's floating a little bit too low. So I'll use the knurled adjustment ring here to increase the height of the floating height of the air spring so that the tubing is a loose fit. Today we'll be showing you guys how to assemble one of our typical CMM platform for one of our customers here. We're getting ready to ship out. This one in particular will be going under a CMM. This is going to a customer that makes stamped parts for the automotive industry. Stamping presses they have running in their facility generate quite a bit of vibration and create issues when they try to create measurements with this machine. This isolation platform, it consists of a steel plate and our biomembrane air springs. The steel plate increases the mass of the machine and helps to lower the center of gravity of the machine itself. And then our air springs will float the steel plate in the machine on a cushion of air and isolate it from the surrounding vibrations. The customer has the machine already in their facility and they were having trouble getting it to calibrate, get proper measurements off of it. So the customer reached out to us and we went and performed a vibration site survey. So we traveled to their manufacturing site and performed the survey there, and based off the results of it, the frequency range that the vibrations were occurring in, it was determined that a bi-air air spring system would be the best option for their application. Based on the results of the vibration site survey, the vibrations that we saw there were out of spec. They exceeded the limits published by the machine manufacturer that were allowable. This platform, we went with a platform option as opposed to just installing the air springs like in the frame of the machine. Because of the footprint of this machine, it's a smaller CMM, so its footprint is a little bit more compact, and then to have the mass of the CMM up higher, the center of gravity of the machine needed to be brought down to maintain stability on our air spring system. Bilz has extensive experience working with customers on a variety of different applications surrounding stamping presses and trying to isolate stamping presses from vibrations, trying to isolate other machines from the vibrations the stamping presses are creating. So we've been kind of on both sides of the fence with that. In most cases, we're able to resolve the issues the customers are having due to the vibrations in their facility, and they're able to measure parts accurately and precisely and efficiently.